Hello and welcome to my channel. In this video, we're going to be talking about one of the most mysterious and fascinating objects in space, black holes. What are they, how do they form, and what happens once you cross the event horizon? We'll be covering all this and more in today's video, so let's get started. What are black holes? To understand what black holes are, we first need to talk about gravity. Gravity is what keeps our feet firmly planted on the ground, and what keeps the Earth orbiting around the Sun. But what happens if you have a lot of mass in a small amount of space? The gravity becomes incredibly strong, and at a certain point, it becomes unrelenting. This means that anything that gets too close, including light, can't escape. This is called a black hole, a region of space where the gravitational pull is so strong that nothing, not even light, can escape. How do black holes form? Black holes form when a massive star runs out of fuel and collapses in on itself. When a star dies, it usually explodes in a massive supernova, but if the star is large enough, it will continue to collapse in on itself until it becomes a black hole. There are three types of black holes: stellar, intermediate, and supermassive, with the latter being the largest of the three. Stellar black holes are the most common, and are formed by the collapse of a single massive star. Intermediate black holes are black holes with mass greater than stellar black holes but less than supermassive black holes. They have masses that range from hundreds to tens of thousands of times the mass of the Sun. On the other hand, supermassive black holes are the most massive type of black holes, with masses ranging from millions to billions of times that of the Sun. They are found at the center of most galaxies, including our Milky Way, and are thought to have grown over billions of years by merging with other black holes in gas clouds. Intermediate and supermassive black holes are mostly identified through their indirect effects on stars and matter that surround them. Such a way that intermediate and supermassive black holes have the strong gravitational pull. What is the event horizon? Now, let's talk about what happens when you cross the event horizon. The event horizon is the point of no return. Once you cross this threshold, there's no coming back. This is because the gravitational pull is so strong that even light can't escape. If you were unlucky enough to cross the event horizon, you would be stretched into a long, thin stream of atoms in a process called spaghettification. At the event horizon, the escape velocity required to break free from the black hole's gravity is equal to the speed of light. This means that anything that gets close enough to the black hole to cross the event horizon will be trapped forever. The size of the event horizon of a black hole is determined by its mass. The more massive a black hole is, the larger its event horizon will be. For example, the event horizon of a stellar black hole with a mass of 10 times that of the Sun would have a radius of about 30 kilometers, less than 20 miles. The event horizon of a supermassive black hole with a mass of 1 billion times that of the Sun would have a radius of several billion kilometers. Discuss about what inside a black hole? So, what happens inside a black hole? Well, we don't really know for sure, as no one has ever been able to observe the inside of a black hole. However, based on our understanding of physics, we know that everything that enters a black hole is crushed into a single point called a singularity. It's a place where time and space as we understand them no longer exist. Let's go in detail. According to current theories, at the center of a black hole lies a point of infinite density called a singularity, which is surrounded by a region of spacetime called the inner horizon or the Cauchy horizon. This region is where the strong gravitational forces become so extreme that not even light can escape, and the laws of physics as we know them break down. Beyond the Cauchy horizon, the curvature of spacetime becomes so severe that even time becomes distorted, and it is unclear what might happen to any matter or energy that enters this region. Some theories suggest that in the extreme conditions of a black hole, the usual laws of physics could break down entirely, and new physics may be needed to fully understand what happens inside. Overall, the interior of a black hole remains one of the greatest mysteries of modern astrophysics, and its study is likely to continue to be a focus of research for many years to come. Examples of black holes which near to our solar system. V616 Monocerotis, which is located about 3,000 light-years away from us. Sagittarius A, SGRS Cygnus X1. D404 Cygni. GRS 1915 plus 105. Ton 618. Conclusion. So there you have it, a brief introduction to black holes. Though they may seem like something out of science fiction, they are very real, and are an important part of our universe. We still have much to learn about black holes, but as technology advances and we continue to study the cosmos, we're sure to uncover more about these fascinating objects. In next video I will make a video on the black holes I have mentioned above. Thanks for watching, and if you enjoyed this video, please hit the like button and consider subscribing for more videos about space and astronomy.